All right, so today we're diving into something pretty fascinating.
Yeah.
FLAH radiotherapy.
Yes.
You know how conventional radiation for cancer
Right.
can be such a drag? I mean,
Yeah.
it takes weeks and weeks and
Yeah.
often has some really difficult side effects.
Mm-hmm.
Well, FLAH is being hailed as a potential game changer,
Yeah.
promising faster treatment and fewer of those nasty side effects.
Absolutely.
We've got your articles right here, and honestly,
Yeah.
some of this stuff sounds almost too good to be true.
It's really exciting. Full-flash H radiotherapy is still in its early stages, but the research so far is incredibly promising.
Okay, so first things first.
Yeah.
What exactly is FLAH radiotherapy?
Right.
It sounds kind of like something out of a comic book.
Well, it's all about speed.
Okay.
Conventional radiotherapy delivers radiation over several minutes, but FLAH blasts the tumor with ultra-high doses of radiation in incredibly short bursts.
Okay.
Milliseconds.
Whoa, so it's like a lightning strike of
Yeah,
radiation.
you can think of it that way.
That does sound pretty intense. Yeah.
But how does that actually translate to fewer side effects?
That's the really intriguing part. It seems this ultra-fast delivery creates something called transient hypoxia,
Okay.
a temporary oxygen-depleted environment in the tissues being treated.
Got it.
And get this, healthy cells are actually better at handling this low oxygen situation than cancer cells.
So FLAH is basically exploiting a weakness in cancer cells.
Exactly.
That's pretty clever.
Yeah.
I'm starting to see why there's so much buzz around this.
And the potential benefits go beyond just fewer side effects. Early studies are showing that FLAH may be just as effective, if not more effective, than conventional radiotherapy at controlling tumor growth.
Wow. So it's potentially hitting harder and doing less damage at the same time.
Yeah.
That's a win-win.
Absolutely.
And didn't I read something about FLAH treatments being much shorter overall?
You're absolutely right. Imagine going from weeks of daily radiation sessions to just a few ultra-fast treatments.
Wow.
Maybe even a single treatment in some cases.
No more endless trips to the hospital.
That would be huge.
Yeah, it would be an incredible improvement for patients.
Okay, so how did we even get to this point?
Yeah.
Where did this whole flash thing come from?
It's a fascinating story, actually.
Yeah.
The origins of flash radiotherapy can be traced back to CERN.
Wait, CERN?
Yeah.
Isn't that the place with the giant particle accelerator? The one that smashes atoms together?
The one and only.
What does that have to do with cancer treatment?
It seems surprising, right?
Yeah.
But it's a great example of how breakthroughs in one area of science can have unexpected impacts in other fields.
Okay.
Researchers at CERN were collaborating with doctors at the Lausanne University Hospital, CHUV, in Switzerland, and that's where they first started experimenting with this ultra-fast radiation delivery.
So we have particle physicists to thank for this potential cancer treatment breakthrough.
In a way, yeah.
That's pretty wild.
Yeah.
And from there, they started testing it out on actual patients.
Well, first they had to do a lot of research in the lab and then in animal studies.
Right.
But eventually, yes, they moved on to human trials. And those early trials have been really encouraging.
Okay.
One of the first, called the FAST-T01 trial, showed that flash was safe and effective in treating painful bone metastases.
Interesting.
In fact, 67% of the patients in that trial experienced significant pain relief.
That's incredible. 67%.
Yeah.
That's a really significant number.
Yeah, it is.
Are there any other trials going on right now?
Yes. There's another one called FAST-T02, which is happening at the Cincinnati Children's University of Cincinnati Medical Center Proton Therapy Center.
Wow, what a mouthful.
I know, right?
Okay.
This one is looking at cancers in the bones of the chest, so it's testing FAFlash in a different patient population.
Okay.
The results from this trial will be really valuable in helping us understand the potential of FAFlash for different types of cancers.
This is all so fascinating.
Yeah.
Okay, so we've talked about what FAFlash is and why it's so exciting.
Right.
But how does it actually work?
Yeah.
What's the tech behind all of this?
It's not necessarily about inventing brand new machines.
Yeah.
What researchers are doing is modifying existing equipment, like linear accelerators, synchrotrons, and even proton accelerators to be able to deliver those super fast doses of radiation.
So they're basically souping up the technology we already have.
Exactly.
That's pretty clever.
Yeah,
And probably a lot more cost-effective than building something entirely new.
absolutely. But of course, there are still some technical hurdles to overcome.
Like what?
They're working on things like increasing beam current limits, boosting repetition rates, and developing more powerful RF sources to really fine-tune the delivery of FLASH.
It sounds like building a supercharged race car for zapping tumors.
You could say that.
But I'm curious, we've talked about the speed and the oxygen thing.
Right.
But are there other biological mechanisms at play here that make fell flash so unique?
There are. For example, research suggests that fell flash causes less DNA damage and fewer chromosome abnormalities in healthy cells compared to conventional radiotherapy.
So it's a more targeted and less damaging approach overall.
It seems to be.
That's really remarkable.
Yeah.
It seems like fell flash is really turning what we know about radiation therapy on its head.
It is. And scientists are still working to fully understand all the complexities of what they're calling the fall effect.
Okay.
It's this combination of factors that seems to give fall ash its unique edge.
The phalange effect. I like it. And I'm guessing that's translating into some real-world clinical benefits.
Absolutely. We already mentioned the pain relief seen in the bone metastasis trial.
Right.
But there's also some very promising preclinical data showing that phalange can significantly reduce lung fibrosis, which is a serious side effect of conventional radiotherapy for lung cancer.
That's a huge deal for lung cancer patients.
It is.
Okay, I'm completely blown away by all of this.
Yeah.
This alpha-ash technology is sounding more and more like the future of cancer treatment.
It definitely has the potential to be a game changer. In the next part, we'll delve into what that future might look like, the potential impact of flash on cancer treatment as a whole, and some of the incredible advancements that are happening right now. Stay tuned.
Welcome back to our deep dive into flash radiotherapy.
Okay, I'm ready for more. That last part was mind-blowing. Honestly, I can't stop thinking about the potential of this aphasia technology.
It is pretty remarkable.
It really seems like we're on the verge of something truly revolutionary in cancer treatment.
I agree. The possibilities with flash are incredibly exciting. What we've seen so far in the lab and in early trials is just the tip of the iceberg.
So paint me a picture. What could the future of cancer treatment look like if flash lives up to all the hype?
Well, for starters, imagine a world where radiation therapy isn't this drawn-out, grueling process that it often is today.
Yeah.
Instead of weeks or even months of daily treatments.
Right.
We're talking about the potential for condensing that down to just a few days of flash therapy.
Okay.
Maybe even a single treatment in some cases. Wow. Just let that sink in for a moment.
Yeah.
A single treatment to target a tumor? That would be absolutely life-changing for so many people battling cancer.
Absolutely. Think about the impact on patients' lives.
Yeah.
No more exhausting daily trips to the hospital.
Right.
No more weeks or months away from work and family.
Right.
And potentially fewer of those debilitating side effects that can make treatment so difficult.
It's almost hard to fathom the positive ripple effects that would have, not just for patients, but for their families and loved ones too.
I agree.
And let's not forget the potential impact on healthcare systems.
Right.
Shorter treatment times could mean shorter waiting lists.
Yeah.
Giving more people faster access to this potentially life-saving therapy.
That's a really crucial point. Equitable access to treatment is a major concern in healthcare.
Yeah.
And fellowship could play a significant role in addressing that, especially for patients with hard-to-treat cancers.
Right.
Who might not respond well to conventional therapies.
So FELH could be a game changer on multiple levels.
Yeah.
For individual patients.
Yeah.
For healthcare systems as a whole.
Mm-hmm.
And potentially even for the way we approach cancer treatment in general.
Mm-hmm.
I'm getting chills just thinking about it.
It's definitely an exciting prospect. And the really exciting part is that we don't have to wait decades to see some of this potential come to fruition.
Oh, really?
The first real clinical trials for FLASH are scheduled to begin as early as 2025.
Wow, that's right around the corner.
It is.
So we're not just talking about some far-off sci-fi concept here. This is happening now.
It's happening.
But I'm curious, aside from refining the delivery of FLASH itself, are there any other advancements happening that could further boost its impact?
Absolutely. There are some really cool things happening in related technologies.
Okay.
For instance, there's a device being developed called FlashDeep.
FlashDeep?
Yeah, which is a joint project between CHUV CERN and a company called TheraQ.
Wait, so the same folks who pioneered FLASH are now working on taking it even further.
They are.
Tell me more about this FlashDeep device. What makes it so special?
Well, FlashDeep is designed to deliver flash radiotherapy to a wider range of solid tumors, including deeper-seated tumors that might have been difficult to target with previous methods.
Ah, so this could potentially open up flash therapy to even more types of cancer.
Exactly.
Yeah.
And that's just one example of the innovation happening in the field. As scientists continue to unravel the biological mechanisms at play and push the boundaries of the technology, we're likely to see even more groundbreaking advancements in the years to come.
That's pretty exciting.
It is. It's like we've unlocked a door to a whole new realm of possibilities in cancer treatment.
This is all incredibly promising, but I know you're also a voice of reason in all this excitement.
I try to be.
So let's talk about the flip side.
Okay.
What are some of the unknowns or challenges that still need to be addressed with flash radiotherapy?
You're right. It's important to balance enthusiasm with a healthy dose of caution.
Right.
While the early results with flash are very encouraging,
Yeah.
we still need to gather more data,
Okay.
especially long-term data,
Okay.
to understand the full picture.
So we need to follow patients who've received flash therapy for a longer period to see how they do down the road.
Right.
Make sure there aren't any unexpected long-term effects or complications.
Exactly. Long-term efficacy and safety are still key questions that need to be answered. Another area of active research is how flash interacts with other cancer treatments,
Okay.
like chemotherapy, immunotherapy, or surgery.
So how it fits in with everything else.
Exactly. Will it be compatible with these existing approaches?
Right.
Will there be any negative interactions? These are all things that scientists are working to figure out.
That makes sense.
Yeah.
We need to understand how flash fits into the bigger picture of cancer treatment as a whole.
We do.
And of course, there's the issue of accessibility.
Right.
Even if flash turns out to be everything we hope it will be.
Mm-hmm.
How do we ensure that it's available to everyone who could benefit from it, not just a select few?
That's a critical question. Right now, flash is still very much in the research and development phase. It's being offered at a limited number of specialized centers around the world.
Yeah, I imagine so.
As the technology becomes more refined and widely adopted,
Right.
we need to make sure that it doesn't become yet another treatment that's only accessible to the wealthy
Right.
or those living in certain geographic areas.
I think that's a really important point to raise.
It is.
We can't let LVASH become another example of healthcare disparity.
Right.
The potential benefits of this technology are just too great to be limited to a select few.
Absolutely. And it's not just a matter of making the technology itself available. We also need to ensure that healthcare professionals are properly trained to administer flash therapy safely and effectively.
That makes sense.
This will require investment in education and infrastructure to support the widespread adoption of this new approach to cancer treatment.
It sounds like there's a lot of work ahead, but also a lot of potential for positive change.
Definitely.
This conversation has really opened my eyes to the complexities of bringing a groundbreaking technology like flash from the lab to the clinic,
Yeah.
and ultimately to patients who are desperately in need of new treatment options.
It's a journey with many moving parts. The science, the technology, the clinical trials, the ethical considerations, and the logistics of implementation.
Wow.
But the potential rewards are immense. If FELS lives up to even a fraction of its promise, it could truly transform the landscape of cancer care.
Well, I'm definitely feeling inspired and hopeful after learning about all of this.
That's great to hear.
It's amazing to think that something as seemingly simple as changing the speed of radiation delivery could have such a profound impact on cancer treatment.
It's a testament to the power of scientific inquiry and the incredible things that can happen when researchers from different fields come together with a shared goal.
Right.
In this case, it's the goal of finding better, more effective, and more humane ways to treat this devastating disease.
Well said.
Yeah.
I'm excited to see what the future holds for FASH radiotherapy,
Me too.
and I'm sure our listeners are too. We've covered a lot of ground today,
We have.
from the origins of FASH to its potential impact on the future of cancer treatment.
We've explored the science, the technology, the challenges, and the opportunities. And while there are still many unknowns, one thing is clear. FLASH radiotherapy represents a beacon of hope for countless individuals battling cancer,
Yes.
and a reminder that we are living in an era of remarkable scientific advancement that has the potential to transform human health.
I couldn't agree more. In our final part, we'll wrap up our deep dive into FASH radiotherapy with some key takeaways and some final thoughts to ponder as we continue to navigate this exciting new frontier in the fight against cancer. Don't go anywhere. Welcome back to the deep dive. We've been exploring this amazing new technology, FASH radiotherapy, and honestly, it's been pretty mind-blowing.
It really has.
It feels like we're on the cusp of a whole new era in cancer treatment,
It does, doesn't it?
right? Like, how do we make sure everyone who could benefit from FASH actually has access to it?
Right.
We don't want this to become some exclusive treatment that only certain people can get.
Exactly. Equitable access is a huge concern. Right now, FASH is mainly being offered at specialized research centers. But as it becomes more established, we need to figure out how to make it available to patients everywhere, regardless of their location, socioeconomic status, or any other factors.
It's like we need to be thinking about the logistics of rolling out FASH on a global scale, right?
Yeah, we do.
And that probably involves a lot more than just having the machines themselves.
Oh, absolutely. We need to make sure healthcare systems are ready to handle FLASH. That means training doctors and nurses on how to use the technology properly and safely. It also means thinking about the costs involved and how to make sure Flash is affordable and accessible to everyone who needs it.
So it's a big undertaking, almost like a whole paradigm shift in how we approach cancer treatment.
Yeah.
But the potential payoff is huge,
Yeah.
right? If we can make Flash work for everyone, it could really transform the way we think about and treat cancer.
Imagine a world where radiation therapy is no longer this long, drawn-out ordeal. Instead, it becomes a much faster and more targeted treatment with fewer side effects. That would be a game changer, not just for patients, but for their families and for society as a whole.
It's almost like a ripple effect of positivity, starting with the individual patient and spreading outward.
Yeah.
Okay, so we've talked about access, but what about the science itself?
Yeah.
Are there still things we need to learn about Flash before it becomes the go-to treatment for cancer?
Absolutely. While the initial research is very promising, we need more long-term data to be absolutely sure about the efficacy and safety of Flash. We need to follow patients for longer periods to see how they do years down the road, not just in the immediate aftermath of treatment.
So even though there's all this excitement about Flash, there's still a healthy dose of caution from the scientific community.
There should be.
We need to make sure we're not getting ahead of ourselves.
Right.
And that we're doing things carefully and responsibly.
For sure. And there are other scientific questions that need to be explored. For example, we're still learning about all the biological mechanisms at play in Flash and how it interacts with other cancer treatments like chemotherapy or immunotherapy. We need to make sure it works well with existing approaches and that there aren't any unexpected complications.
So there's a lot of ongoing research to be done, but it sounds like it's all moving in a really positive direction. It's pretty incredible to think that something as seemingly simple as changing the speed of radiation delivery could have such a profound impact on cancer treatment.
It really is. It's a testament to the ingenuity of the scientists and researchers who are working on this. They're taking what we thought we knew about radiation therapy and turning it on its head.
It really makes you appreciate the power of scientific discovery.
Yeah.
Okay, as we wrap up our deep dive into Flash radiotherapy,
Yeah.
what are some key takeaways you'd like our listener to remember?
I think the biggest one is that Flash has incredible potential to transform the landscape of cancer care. It could make treatment faster, more effective, and less burdensome for patients. But it's important to remember that we're still in the early stages, and there's a lot more research to be done before Flash becomes widely available.
So it's a story of hope and promise, but also a story of ongoing scientific inquiry and careful consideration of all the factors involved in bringing a new technology to the world.
Exactly. And I think it's also a story of collaboration. The development of Flash has involved scientists from different fields, physics, biology, medicine, working together toward a common goal. That kind of interdisciplinary collaboration is essential for pushing the boundaries of scientific knowledge and finding solutions to complex challenges like cancer.
Well said. It's been an amazing journey exploring Flash radiotherapy with you today. I don't know about you, but I'm feeling incredibly optimistic about the future of cancer treatment after learning about all of this.
I am too. It's inspiring to see the dedication and creativity of the people who are working to make this technology a reality. It gives me hope that we can continue to make significant strides in the fight against this devastating disease.
And for our listener, if you're as fascinated by FLAH radiotherapy as we are, we encourage you to stay informed about the latest developments in this field. It's a rapidly evolving area, and who knows what incredible breakthroughs might be just around the corner.
Well, thanks for joining us on this deep dive into FLAH radiotherapy. It's been a pleasure sharing this exciting new frontier in cancer treatment with you.
Until next time, keep exploring, keep learning, and keep diving deep into the world of knowledge.